Now, runtime polymorphism is what? Memory allocation at runtime is done. Okay, we already discussed in the second unit, I think, this topic. Memory allocation, which is done at runtime, this is called the runtime polymorphism. So, their object is bound to the function call at the time of the execution call. Your object is bound to the function call at the time of the execution. Also, it is termed as the late binding. It is termed as the late binding. As it is a runtime polymorphism, it is also called as a late binding. And whereas the compile time polymorphism is called as the early binding, where the function is binded with the object at the compilation time. So in this function, call is resolved at the time of runtime. So object is allocated or particular function at the time of the execution time. So that is called late binding. Okay. So here the compiler determines the type of object at the runtime and then binds the function call. So till that point, compiler is not knowing about the that particular function, which function has to be taken along with the object, which function has to be taken along with the object. Okay, so the concept of virtual function is there. This also we discuss. A function in base class which is overridden in the derived class. Which function? A virtual function. A function in the base class which is overridden in the derived class. So virtual function are the function which are only written in the base class, but it is defined in the derived class. So it is again tells the compiler to perform the late binding on this function. So virtual functions are the type of the late binding functions. Okay, so we call the virtual functions at the time of execution, right? So virtual functions are called at the time of execution, not at the time of compilation. Okay, so virtual keyword is used to make a member function of the base class as the virtual. Once you write the keyword virtual in front of the member function of the base class, that becomes the virtual. Then that function becomes the virtual function. Once you write the keyword virtual in front of that particular member function. Okay. So this type of things we have discussed in the inheritance, right? There was a topic in the unit 2. There was a topic unit. So basically the virtual functions body is not defined in the base class function. So that is derived in the derived class functions. Derived class functions. Same name is given. Same name is given. Okay. Function name is same in the base class. Only we are overriding that same function name in the derived class. Okay, so that is what you are overriding the base class function with the derived class function. Base class function with the derived class function. So there is a concept of pointer also. We discussed this, a pointer concept in the second unit. A pointer can point to an object of a class like student pointer ptr1. If this is a pointer that can point to an object of a class student. So object pointer are useful in creating objects at the runtime, accessing these public members of an object. So public members means the methods of that methods. Public members means it is the methods. Okay. So this can be accessed with the help of the pointer variable or pointer to the object of that class. So we can write here, for example, if you declare the pointer ptr1, then the method is there. Suppose the get data method is there, that is a member function of the class student. Then it will call, how it will call, with the pointer notation. We don't use the dot notation over here, dot operator. We use here arrow operator. Instead we use here arrow operator. So pointer one, then arrow operator and the name of the method. So name of the method is suppose get data. So it will be called with the help of the pointer. If we are doing this, this means that we are using the dynamic memory allocations over here. Okay, or we are calling the function at the runtime. We are calling the function at runtime. If we use the pointer, we are calling the function at the runtime. So here, suppose another method is pointer one display. So here again pointer one and the arrow operator and the display function called. A base class pointer can point to any type of derived object, but the reverse is not true. Means when we create a base class pointer, it can point to a derived class object, but the derived class object cannot point to the base class. Okay. Incrementing or decrementing a base class pointer pointing to a derived class object cannot make it to point to the next object of derived class. As well as increment or decrement is relevant to its basic base type only. Okay. So here also Incrementing or decrementing a base class pointer pointing to the derived class object cannot make it to point to the next object of the derived class. Same way, we can not have the incrementing for the base class which can point to the next object of the derived class. So this is not possible with the derived class, but it is possible with the base class pointer. Okay. Then the rules for the virtual functions. Virtual function should be member of the sum class. This should be a member of sum class. Virtual functions we cannot write outside. It should be the member function of some class. It cannot be a static, can be a accessed. It cannot be a static. We cannot make the virtual function as a static function. Cannot make the virtual function as a static function. And it can be accessed using the object pointers. How? It can be accessed using the object pointers. Virtual functions can be accessed using the object pointers. But it can be a friend of another class. Okay, so virtual functions can be a friend of another class. Then prototype of the base class version must be the identical to the derived class version. So same prototype is used for the base class version, which must be identical in the derived class version. Okay, so prototype means what? If it is a, you have mentioned it is an integer return type, then the same must be followed in the derived class integer return type. If you have written as a return type float, then same must be followed in the derived class also. So the prototype which you have declared inside the base class must be identical in the derived class version also. Okay. If defined in the base class, need not be necessarily redefined in the derived class. And if it is defined in the base class, we need not necessarily we redefine in the derived class. In such case, call invokes the base function. What is the meaning of this? If you are writing this in the base class definition, then you don't need to write again that definition inside the derived class. And in such case, if you create the object of the derived class, then derived class will invoke first that inside the base class it will search and it will invoke that definition according to the base class function. Okay, it will call upon the base class function. Constructors cannot be a virtual constructors. We cannot write a constructors as a virtual, but we can write the destructors as a virtual. Okay, these are the some rules for the writing the virtual functions. So what is the significance of virtual functions? Virtual function makes the C++ compiler to determine which function to be used at the execution time based on the type of object pointed and not the type of pointer. Okay, object means a class object is there, whether it is a base class or whether it is a derived class or the derived class object pointing to that particular address. So it has a address concept over here. So it will point out at the particular execution time. So making the call execution time at execution time. So not at the compile time. So virtual function makes that a dynamic allocation. So it is not wasting the memory at the static time. It is not wasting the memory at static time. It just create that or allocate that memory at the runtime and then destroy that. Making the base pointer to point to the different derived objects, different versions of virtual function can be executed. Now you can create the base pointer. You can create the base pointer. Now this base pointers can have its copies. Base pointer will have the address at associated with the different derived class objects. Okay, so at the same time, one pointer can have address at one time of one derived object. Once it will execute that particular function, after that you can provide the address of another derived class object and again execute the method. Likewise, it will just create one object and it will executed the different member functions. So for the virtual function, first we should know the what are the pointers, right? So what are the pointers? Pointers can hold the address of the certain variable or certain object. Okay, so we will see the example how we can write this example for the virtual function. Already we discussed this in the second unit. Still we'll discuss this in the form of the virtual functions over here. Class base class name is given. Now in this we are writing if it is a virtual void display one is the name of the function. Now as virtual keyword is attached to it, this means the value you are assigning equal to 0. So what type of this becomes?
Yes,
If
miss.
it's right equal to 0, that means it is a pure virtual function. Now one more concept was there. If a class consists of one pure virtual function, then that class is called as abstract class. So in this case, we have the base class. This base class is an abstract class because it has one pure virtual function. Another also, the virtual void display2 is also saying that is equal to 0. That means this is also a pure virtual function. At least one or more than that, then it happens as an abstract class. Okay. So now third define void display3. Third is void display3. Now here you are writing something, see out the, this is the display3 method of the base class. This is the display3 method of the base class. That means you are printing this statement inside the method which is named as display3. Display1 you are not writing, display2 you are not writing, you are writing at display3. Then this happens for your class which is the base class, which is called as the abstract class as well. Now the another class, derived class, this will derive from the base class. This will derive from the base class as colon and public base classes name is given. So that means the inheritance concept is used here. Now after that you have again written here or defining the definition for the display1 function. As you have written here as a base class, it is a virtual, but it is defining inside the derived class. So you can define the void display1 inside the derived class. So the definition or the statements you can write for the display1. So what you have written for the display1? See out, this is a display1 method of derived class. Then also which you are said that this is a virtual function, its definition you are writing in derived class. Its definition you are writing in derived class. So void display2, again its definition you are writing in the derived class. So this is a display2 method of the derived class. This is the display2 method of the derived class. So you are writing display1 as well as display2, which are written as a virtual functions inside the base class. This, though it is written inside the base class as a virtual function, you can now define it inside the derived class. Okay, with the same prototype, So prototype should be matched there. You cannot write integer display1. You have to write void display1 only because you have written the prototype there as a void display1. So inside this derived class also you have to write void display1 or void display2. You cannot write like float, character or integer. Whatever the prototype which is made in the base class, that has to be followed in the derived class while writing the definition for that particular virtual function. Okay, so we have written the two virtual methods or functions, display1 and display2, and in the derived class we are writing the definition for display1 and display2 functions, right? And one more function we are writing the definition inside the base class itself for the display3. Now this is for a creation of the class, which is one class is the base class, another class is the derived class. Now we have to write the execution point main function over here. So once you write the main function, you have two choices. Okay, one choice is using the derived class object. You just call out the also the methods of your base class methods as well as the derived class methods. Okay, so on left hand side, can you see that derived class int main derived class? Can you see that left hand side? So in this case, derived class and the object created is D, right? So D dot display1, it will call the display1 method. Then D dot display2, it will call the display2 method, and D dot display3, it will call the display3 method. Okay, so this is with the help of the derived class object. The same thing which we have done with the derived class, we can do with the help of pointer. Yes. So when we do this, this is called the dynamic or the this binding is known as which type of binding we are doing if we use a pointer. When we use the pointer, now in the second case here, we write the base class pointer bptr. We declare here pointer. Then we declare the object of derived class. Okay, this is the derived class. This is a derived class object D. Now the next is bptr is equal to ampersand D. That means now this pointer will hold the address of the object D. That means this will now point it to this address where the object is located. Okay, so now once you have the pointer and arrow operator and the method name, you can access this display1, you can access this display2, you can access this display3 using this pointer, which is a base class pointer. Okay, so you can access the methods of the derived class as well as the base class. You can access the methods of the derived class as well as the base class. Now tell me what will be the output of this example. Display1 is called, display2 is called, display3 is called. This only difference is what you are using late binding over here and you are using early binding here. At the compilation time, this one static memory allocated and this is runtime memory allocated. So using the example of virtual function, you are doing this with the help of this base class pointer. So once you write for the virtual function, you need not have to write this integer main derived class d. You just use the base class pointer and then the object of the derived class and hold the value of that object into the pointer and then call with the help of the arrow operator, not dot operator. The difference is that whenever the pointer is used, method is called with the arrow operator. So tell me what is the output for this program? Another program, just tell me what is the output for here. See, you have written this in derived class display1. What is there? Cout statement. This is display1 method of derived class. This will be the first output. Yes.
Yes.
Then
Yes, ma'am.
second statement.
Void display to
Huh.
this display to
Huh.
method of
Method of
derived class.
derived class. And third one. This
Display
is
3 method of the base
base
class.
class, right?
Base, yes.
Okay. So likewise, we have called upon this with the help of the virtual functions. We have used the virtual function in our base class. We have redefined it. We have redefined it in the derived class. Whenever the virtual functions are used, you have to use the pointer concept for the for the method calling of the derived class as well as for the method callings of the base class. Is it clear? So we'll move to the next example. So second example is again for the one class is given shape in that the variables are put up double, that is the double width and height. Then in public we are writing the method void set data double A and double B. Here we are assigning the value, that is a parameter passing. So width is equal to A and height is equal to B. Similarly, some function area, because here we are not specifying the type of derived class, we are going to specify in that the definition of this method area. So in the shape class, we are just defining that area as a pure virtual function with the help of keyword virtual, and we are assigning equal to 0 value. That means this becomes a pure virtual function. Now, what is the name? What is the shape class is called as in this case, as it is having the pure virtual function? Shape class is called as
Abstract.
abstract class because it consists of one
More than one virtual function.
function. Yes. Now, second, this is class rectangle. This is a derived class. Why this is a derived class? Because there is a colon. Publicly, it accesses the shape as a base class. So now the double area here you are defining, which is a virtual over here in the derived class area you are defining. So whatever the values of width and height you are just taking and you are returning that value for the area. Multiplication is done and then you are returning this. Similarly for the class triangle, you are doing class triangle colon public shape. Then your method is that virtual method in base class you are defining over here, that area. Again area you are returning the width multiplied by height divided by 2. This value you are returning to the function called area, function which is called area. Okay, so basically these are the shape is a base class where you have not provided the definition, but you are providing the definition of area in its derived classes. Two derived classes are there. One is the rectangle, another is the triangle. See, this is the class triangle colon public shape. So this is two derived class. One is rectangle, another is the triangle. Now we have to again in the same way you have to call with the help of the base class pointer. We have to use the base class pointer. So in this example also we can write the base class pointer, declare it, shape is there base class, pointer sptr, then rectangle is a derived class, write the object rect, then sptr, this is what the base class pointer is equal to ampersand rect. That means you are putting the address, of object of the class rectangle where it will now pointed by this pointer of the base class. Now base class method needs to access, so just use sptr arrow operator set data. You can pass, because it is a parameter, passing the value 5 and 3 to this set data method. It will call out this method. Which method? Set data of the base class. Set data double a double b, width is equal to a, height is equal to b. So width 5, height 3. If this got into the definition value. After that you are calling the area method of the rectangle class. So your statement is cout area of rectangle is. Now you are using the pointer sptr, which is the pointer base class pointer, arrow operator, and the name of the method, which is written inside the rectangle class. So you are calling area. You are calling area over here. Okay, you are calling the area over here. So calling area will return the value over here. What value will be written over here? Area of rectangle is, as the output, when you run this program, area of rectangle is 15 will be printed. Okay, for up till now. Other remaining part is there. Again, triangle tri, this is an object of the another class, which is a derived class, which derived from the shape class. Once again your pointer of the base class sptr you are using is equal to ampersand tri. This is the object of triangle class. So this time you are assigning the value, address value, inside the base pointer of triangle object, tri object. Now this will again used the method, because now it is pointing to the triangle object. Again sptr arrow operator set data, it will set out or call out the method of the base class 4,6, which is written into the base class. It will assign the value to the that width and height variable. Okay, width and height variable, and then again it will print out cout statement area of triangle is. Now you are calling again the area method, but this is what? Area method of triangle class.
Triangle.
Triangle class. Okay, so this time the address of the triangle class object is there. Okay, tri, this object holds this by the pointer. So now this time the method area will be called, which is written as a return statement is what? Return width multiplied by height divided by 2, divided by 2, and the value will
Integer.
get, yes, value
By
will be
12.
value. Yes, value will be get printed over here. So the area of triangle is the value 12 will be printed over here. So once the base pointer usage is over, it will be again deallocated. So it is allocated at the runtime and it is deallocated at the runtime. So this is one of the usage using the virtual functions. And here the concept of virtual function in the polymorphism. So there are two types of polymorphism we have seen. One is the static time polymorphism, another is the compile time that is a static time, compile time is one, another is the runtime. So in runtime the virtual function concept is there, and through the virtual functions we can allocate this with the help of the base class pointer, this concept of virtual function. Okay, so we'll right now we see this examples of virtual function. Two example we discuss over here. If you want again some examples you want to discuss, then we will discuss in the next lecture. Okay.